Hello everyone. So today I'm going to discuss a very important topic, that is distribution based in permutation and combination. So now I have already prepared a total, means we can say that the total concept based sheet. Okay, and I will discuss each one concept from this one sheet. So now, so basically in permutation combination, the distribution based problems, there will be mainly four types of cases. So distribution of n articles in R boxes, or distribution of n articles among R persons. Okay. So four cases may be identical articles in identical boxes, identical articles in different boxes, different articles in identical boxes, and different articles in different boxes. Okay. So now we are going to discuss, or we are going to understand the different cases. The first one case I'm going to discuss here, when no box remains empty or no box is empty. Okay, means at least one article must be kept in one box. Okay, so now example number one. In how many ways we can distribute five identical balls in three identical boxes when no box is empty? Okay, so as we can see, there are five identical balls, this, and this. And now we have to keep these boxes in three identical, means these three balls in three identical boxes. Okay, so the first one case is identical to identical. Okay, so first one thing, there are so many ways, but remember one more thing. When we are using identical things, okay, I have already discussed in the class that when some things are same and when the articles are same, then number of ways of arrangements of those things will always be equal to 1. Okay, so now we have to keep these five balls in these three boxes. Balls are identicals, boxes are identicals. Okay, so these three balls can be kept in 2 2 one way and 3 1 one way. Means two balls in first one box, two balls in second one box, and one ball in third one box. Similarly, we can say three balls in first one ball in second one, and one ball in third one. So because balls are identical, so they can be kept only in one way, and second one is the another one way. So total number of ways will be two ways in this one case. Okay, now we can also understand this one thing in one more way, just by using the partition method. Okay, now identical balls in are identical boxes. So first one thing, partition method is, because no box remains empty, so we will do one thing. One ball must be kept in each one box, in each one box. Okay, so now the remaining number of balls will be 2. Now we have to keep these two balls in these three boxes, because the condition is already fulfilled, means no box is empty. So now we have to arrange remaining two balls. So remaining two balls can be arranged in 2 0 0, means we can put two balls in one bag and remaining two others, and the other two boxes, okay, they will have only one ball in it. And we can also break down these two balls in two equal parts, means one ball and one ball. So we can put these balls in 1 1 0 way. Means one, means suppose that in first box we are putting one ball extra, second one box one ball, and third one box will contain only one ball. Okay, so simply we can say that this is the way of 2 2 1, already discussed in the first one part. Okay, so now for a bigger value of n, for a bigger value of n, we will use this type of partition method. This is a theorem. Okay, PNR equals to summation Pn minus r comma k, and the value of k will be equals to 1 to r. And why we are subtracting r from it? R means no box remains empty. Clear? When r boxes are here, then each one means at least one ball must be kept in each one box. So if there are suppose that if there are 9 identical balls, example one more, and 3 identical boxes, and no box remains empty, it means we have to keep one ball in each one box. So remaining number of balls will be 6. Okay, so we have to distribute 6 balls in 3 identical boxes after this one. So p n comma 3 will be equals to p n minus 3 comma k. N minus 3 will become 6. Means we have already kept 3 balls in 3 boxes. So now remaining 6 balls will be arranged or will be distributed in each one box. In how many ways? 6 comma 1, 6 comma 2 and 6 comma 3 ways. Where 1 is the value of k, means we will start the value of k from 1 till 3, which is equal to number of boxes. Okay, 6 1 6 2 6 3. Now what is 6 1? P61, this is not permutation. Okay, so P61 means partition 61, means we have to divide 6 balls in one part only. So one part it will remain 6 only, means in one way. Clear? Now we have to divide 6 in two parts. So how can we divide 6 in two parts? 2 plus 4 or 3 plus 3? Two ways. Now we have to divide 6 in three parts. So in how many ways we can divide 6 in three parts? So in three ways, that is 1 plus 2 plus 3, 1 plus 1 plus 4, and 2 plus 2 plus 2. So three ways. So one way, two way, and three way. So total number of ways will become 7. Clear? So first one is identical balls in identical boxes. I think this point is clear. Now second one case, when balls are identical but boxes are different. So suppose that 5 balls, these are the identical balls, and boxes are different. Different means the boxes must be labeled as suppose that A, B, and C. Okay. So if no box remains empty, so how can we distribute the balls? So balls can be distributed in two ways, 2 2 1 or 3 1 1. No box remains empty. So now because balls are identical, so order of balls is not important, but the order of boxes is very important. So now, two balls in first one box, two balls in second one box, and one ball in third one box. But this order can be interchanged. Means 2 1 2, 1 2 2. So how can we arrange these three things? So these three things can be arranged in 3 factorial ways. But out of these three things, two are same. So we have to remove the arrangements of similar things. So 3 factorial divided by 2 factorial, it will be 3. And similarly, second one is 3 1 1. So these three things can be arranged in 3 factorial ways, but two things are same. So we have to remove the number of ways of similar things. So we can say that 3 factorial divided by 2 factorial, it is 3. So now the total number of ways will become 6. Okay, sure. Because balls are same. So we can say that the arrangement of similar things must be removed from it. So similarly, we can use one more formula for it. Number of ways. Okay, when n identical things are to be distributed among or in r boxes, so it will be equals to n minus 1 c r minus 1. So where n is the total number of balls 5 and r is the number of boxes 3. So 5 minus 1 c3 minus 1, it will be 4c2, that is 6. Okay, one more method we can use here, using separators method. Separators method means, First one thing, 5 balls will be there, 5 identical balls. Okay, so first one, no box remains empty. It means one ball must be kept in each one box. Okay, so now the remaining 2 balls should be distributed. Okay, in 3 boxes. So in how many ways we can do this one? So 2 boxes are identical. So separator means we have to divide these balls in 3 parts. So remember one thing, when anything is to be divided in 3 parts, so we have to use 2 cuts. Means 2 cuts are required. Suppose that there is a rod and we have to divide this one rod in 3 parts. So 2 cuts will be required. If there is a rod, you want to divide it in 4 parts, so 3 cuts are required. So similarly, these two things are here and we have to divide it in 3 parts. So when we want to distribute or divide anything in 3 parts, so 2 cuts are required or 2 separators are required. Okay, so 2 similar balls and 2 similar separators, means cuts will look like same. Okay, so number of ways in this one case will be, so now 4 things are here. So these 4 things can be arranged in 4 factorial ways. But out of these 4 factorial, 2 balls are similar and 2 separators are similar. So arrangement of similar things must be removed. So it will be 4 factorial divided by 2 factorial into 2 factorial. 2 factorial for 2 similar balls and other 2, the second one 2 factorial is for 2 similar separators. So it will be 24 upon 4, that is 6. So in one more way we can solve this one question. Another. So now case 3. When different balls are to be arranged in identical boxes or kept in identical boxes, suppose that 5 different balls in 3 identical boxes. Now balls are different but boxes are same. So now I'm going to use this one method. So first one, in how many ways we can distribute the balls? So 2 2 1, okay, and 3 1 1 in this one way. So first one I am going to discuss this one method. So in first one box we have to put 2 balls, any 2 balls. So total number of choices are 5. So out of 5 balls we have to select 2 balls. So 5C2. Now 2 balls selected or 2 balls has been kept in first one box. So now remaining, so in the second one box we have to put next 2 balls. So and in this one case the number of choices will become 3. So 3C2, and last one box will be kept in the third one. Last one ball will be kept in the third one box. So 1C1. Okay. So it will be 5C2 10, 3C2 3, and 1C1 1 divided by 2 factorial. Why? Because in two boxes are similar. Boxes are similar and balls will be kept inside it. So after keeping the balls inside the boxes, the box will look similar. So we have to remove the number of ways of similar things because we have to arrange them. Okay. So similar things arrangements must be removed in because 2 similar things are here. So it will be divided by 2 factorial. So after solving this one, we will get 15. And similarly, if the case is 311, so 5C3 into 2C1 into 1C1 means first one we have to choose 3 balls out of 5C3 ways. Now 3 balls selected. So after putting 3 balls in first one box, now we have to choose 2 balls. No, sorry. We have to choose 1 ball from the remaining 2 balls. So it will be 2C1 in the second one box. And last one box should be kept in the third one. Last one ball should be kept in the third one box. So it will be 5C3 10, 2C1 2, and 1C1 1. But divided by 2 factorial again. Why? Because 2 boxes will look like same. So 2 factorial, it will become 10. So 15 plus 10, it will be 25. But we can use one more way. Means this method can be reduced in one more way. So as we can see here, because 5 balls are different, so different things can be arranged in 5 factorial ways. Clear? But in these 5 factorial ways, remember one thing, the order inside the bag is not important. Means suppose that if we are putting b1 and b2 in first one bag, so it is not important that we are putting b1 b2 and the second one b2 b1. No, inside any box the order is not important. So when we are using 5 factorial, it means we are arranging or we are taking all the orders, because inside the box order is not mandatory. We can write down b1 b2 or b2 b1. So in so the order inside the box must be removed. So two balls inside first one box, 2 factorial ways, two balls in second one box, again 2 factorial ways, and one box only in the third one box. So you can write down 1 factorial. Okay, into 1 by 2 factorial. Why? Because two boxes are similar. Because all the boxes are similar, and in the first two box we are putting two balls, so they will look like same boxes from outside. So divide by 2 factorial, it will become 15. Now again, 5 balls can be arranged in 5 factorial ways, but inside the box order is not mandatory. So 3 balls order must be removed from 5 factorial. It will be divide by 3 factorial into 1 factorial into 1 factorial, and divide by 1 by 2 factorial. Means into 1 by 2 factorial. Why? Because again two boxes are similar here. So after solving this one, you will get 10. So 15 plus 10, again 25 is the answer. Okay. Now next one. Case 4. When balls and boxes both are different. Okay, both are different. So 5 balls, 3 boxes. So again 5 balls in 3 boxes when no box is empty. So it can be done in 3 1 1 and 2 1 2 2 1. Again 5 balls can be arranged in 5 factorial ways, but the box means when the balls will be kept inside a box, the order of balls inside the box is not important. Okay, so that order must not to be taken. So we have to remove that one. So 5 factorial divided by 3 factorial into 1 factorial into 1 factorial. Okay, but in this one case, as we can see, boxes are different, so there must be an order of the arrangement of boxes. So it must be multiplied by 3 factorial, because boxes can also be arranged. So into 3 factorial it will be 60, and 5 factorial divided by 2 factorial into 2 factorial into 1 factorial, and boxes are different, so arrangement of boxes will be 3 factorial. So after solving this one, you will get 90. So 60 plus 90, the total number of ways will become 150. I think no doubt in this one. Now next one. Again the second type of distribution, when box can remain empty. Okay, so again case 1. Balls and boxes when different balls and different boxes. So 5 balls means 5 different balls in 3 different boxes. So as we can see, each ball can be kept in 3 ways. Means for each one ball there are 3 choices. Okay, b1, suppose that boxes are, if the boxes are abc. Okay, and balls are b1 b2 b3 b4 b5. I'm just writing down here. Suppose that balls are b1 b2 b3 b4 b5, and boxes are a, b and c. All are different. Okay, so b1 ball can be kept in any one of the box abc. So b1 can be placed in 3 ways. Similarly, b2 can also be placed in 3 ways. Similarly, b3 can also be placed in 3 ways, b4 in 3 ways, b5 in 3 ways. So we have to multiply all the ways. So we will get, you know what, 3 raised to the power 5. 3 raised to the power 5 means 243 ways. So remember one thing. Okay, in this one, all the 5 balls can be kept inside one bag also. Okay, so that's why we are choosing 3 ways for each one. Okay, so when n different balls are to be kept in r different boxes, then the number of ways will be r raised to the power n always. Now next one, case second. When identical balls are to be distributed in different boxes, five identical balls in three boxes. So when box may remain empty, so three cases will be here. When two boxes are empty, so when two boxes are empty means all the five identical balls may be kept in one bag or one box, and remaining two boxes will remain empty. Okay, so 500. In how many ways we can arrange 500? Because balls are identical, so there is the order of arrangement of balls is not important, because they can be arranged only in one way. But 500 boxes are different, so three boxes can be arranged in 3 factorial ways, but two boxes will look like same. So 3 factorial divided by 2 factorial, number of ways will be 3. When one box is empty means 4 comma 1 comma 0 or 3 comma 2 comma 0. Now we have to arrange them, because 410 all the values are different, 320 all the values are different. So different things can be arranged in 3 factorial ways. Again the different things can be arranged in 3 factorial ways, means 6 and 6, total number of ways will be 12. And now third one case, when no box is empty. So no box is empty can be done in 122 and 311 ways. So 122, 3 box are to be arranged 3 factorial, but two boxes will look like same, divide by 2 factorial. 3 311 again 3 factorial, divide by 2 factorial. Why? Because the two boxes are same here. Okay, so 3 factorial divided by 2 factorial, again we will get 3. So 3 plus 3 total will become 6. Now the total number of ways will become 3 plus 12 plus 6, it will be 21. This is your answer. Okay, okay. Now one more thing, when n identical balls are to be kept in r different boxes identical to different, then the number of ways will always be equals to n plus r minus 1 c r minus 1, 5 plus 3 minus 1 c 3 minus 1, 7 c2, answer 21. Directly we can use. We can also solve this one question by using separators. Okay, so five things are to be arranged or are to be divided in three boxes, so two separators will be there. Why? Because we have to divide things in three parts. So if you want to divide anything in three parts, so two cuts will be required. So two cuts means two separators are required. So now in this one way, five these things and two separators. So how can we arrange? Because things are identical and separators will also be identical, means cut will always look like same. So these seven things can be arranged in 7 factorial ways, but out of these 7 factorial, 5 things are identical, so divide by 5 factorial, and separators are identical, so divide by 2 factorial. You will get 21. Okay. Next one, case 3. When balls are different and boxes are identical, means 5 different balls can be kept or are to be kept in 3 identical boxes. So B1, B2, B3, B4 and B5. But the boxes are same, they are not labeled. So in how many ways we can do this one? When two boxes are empty, so 500. But remember one thing, in this one way, boxes are similar. So arrangement of similar boxes will remain only in one way. Because if three boxes are to be arranged here and boxes are similar, so arrangement of similar things will always can be done only in one way. So 500 can be arranged only in one way because boxes are similar. When one box is empty, so it can be done in 230, 140. So 230 means because balls are different, so 5 different balls can be arranged in 5 factorial ways. So 230, because inside a box the order of balls is not important. Clear? Same as if in the first one box we are putting B1, B2, B3, so arrangement of B1, B2, B3 inside first one box is not mandatory. Means We cannot say that b1 b2 b3 then b1 b3 b2 and b2 b1 b3. Okay, 6 arrangements. No, means if these 3 balls are kept inside first one box, it will be considered as only one way. So arrangements of 2 balls in first one box or any one of the box must be removed. So 5 factorial divided by 2 factorial. Similarly for 3 factorial division and 0 factorial. So it will become 120 upon 12, that is 10. And now 140, 5 factorial upon 1 factorial, 4 factorial, 0 factorial, it will be 5. So it will become 15 ways in this one case. And when no box is empty, so it can be done in 311 and 221 ways. So 311 means all the 5 balls are different. So 5 factorial, because order of balls inside a box is not important. So 3 factorial into 1 factorial into 1 factorial divided by 2 factorial. Why? Because boxes are similar. So these two boxes will look like same. So same boxes arrangements must be removed. So it will be 2 factorial. So 20 upon 2, it will become 10. Clear? Similarly, 2 to 1. So 5 balls can be arranged in 5 factorial ways, and 2 balls in first one or in any one of the box, their order must be removed, 2 factorial. Similarly for second one, 2 factorial, 1 factorial, and divide by 2 factorial. Why? Again, two boxes will look like same. So 30 divided by 2, it is 15. So total number of ways are 25. Now we have to find out the total number of ways of arrangement. So this is one way, this is 15 ways, and this is 25 ways. So total addition will be equals to 41. Means 1 plus 15 plus 25. Sum is 41. Now case 4. When identical balls are to be arranged in identical boxes. So again we have to just do the partitions. So number of ways will be equals to, means 3 identical boxes. When all the 5 balls are kept in only one box, means 500. So 500, it can be done only in one way because boxes are identical. When we have to divide 5 balls in 2 parts, so how can we divide? Means third one box will remain empty. So in how many ways we can do it? In 1 plus 4 or 2 plus 3, and third one box will contain 0 balls. So 1 plus 4 and 2 plus 3, how many ways are here? 2 ways. Why? Because balls and boxes, they are identical. Similarly, if 5 things are to be divided in 3 parts, so how can we do this one? 1 1 3, 1 2 2, means no box is empty. So again 2 ways. So 1 plus 2, the number of ways will become 5 in this one case. Okay, so I think there is no doubt in the distribution part. Okay, I will also share this one sheet in the form of PDF. Now the questions from your PPT. Find the number of boxes, number of ways in which 120 mobile phones can be shared equally. Can be shared equally. Equally means if one student is there, means we have to divide 120 balls. Suppose that, okay, by using n partitions. If only one student is there, then all the 120 mobiles should be given to one student. If there are two students, so 120 mobiles should be divided in two equal parts, 60-60. If three students are there, so 40-40-40. If four students are there, so 30-30-30-30. Five are there, 24-24-24-24-24. Six are there, 20-20-20-20. So remember one thing, in how many ways we can divide this one. It means we have to find out the how many ways. Means remember one thing, mobile phone can not be distributed just by breaking it. Means number of phones must be divided equally in complete number. So we have to divide 180 in, means we have to find out the value of n, means how many values of n are here which can divide 120 perfectly. Means we have to find out n means number of factors of 120. So how can we find out the number of factors of 120? Recall the number system chapter. When there is a number a and their prime factors are, suppose that 2 3 5, and 2 raised to the power a into 3 raised to the power b, okay, into 5 raised to the power c into dot dot dot, then total number of factors will be equals to, increase the powers by 1 means it will become a plus 1 into b plus 1 into c plus 1 into d plus 1 into dot dot dot. So now similarly we have to find out the number of factors of 120. So first one, divide 120 into prime factors. So 120 can be divided in 2 into 2 into 3, no sorry, 1 minute, 2 into 2 into 2 into 3 into 5. So it will become 2 raised to the power 3 into 3 raised to the power 1 into 5 raised to the power 1. So total number of factors will be equal to, increase the powers by 1 3 plus 1 into 1 plus 1 again into 1 plus 1. So it will become 4 into 2 into 2. It will become 16. So option C is the correct one. In how many ways 5 rings of different types be worn in 4 fingers? Okay, in this one case, finger, any finger may remain empty or unweighed. So we have to divide different things in different boxes. Okay, so different things in different boxes, and boxes may remain empty. So recall the case 1, when boxes may remain empty and different balls in different boxes. So it is the method r raised to the power n. Okay, so similarly in this one case, 5 rings are, okay, can be worn in 4 fingers. Okay, so we can say that for each one ring there are 5 rings, and for each one ring 4 choices are here. 4 choices are here. Okay, so it will become 4 into 4 into 4 into 4 into 4. It means 4 raised to the power 5. It means 2 raised to the power 10. It means 1024. By the way, 1024 is not, means options are given in terms of power. So its answer will be option C, 4 raised to the power 5. Okay, now next one. Find the number of ways in which 8 non-identical apples can be distributed among 3 boys such that every boy should get at least 1 apple and at most 4 apple. Okay, so 3 boys are here. So this can be done in how many ways? Let's check. So this can be done in 1, 3, 4. Second one, 2, 2, 4. Third one, 2, 3, 3. I think no other cases here. So now, because 8 apples are different and boys are also different, so we have to use one thing. Now, 8 things can be arranged in 8 factorial ways, but it should be divided by 1 factorial into 3 factorial into 4 factorial. Okay, it should be divided by into 1 factorial into 3 factorial into 4 factorial. Why? Because suppose that if second one boy is getting 3 apples and the suppose that apples are different, so they will be marked as A1, A2, A3, A4, A5, A6, A7, A8. Suppose that second one boy is getting A3, A4 and A5, these three apples. Then A3, A4, A5, A5, A3, A4. So means these orders will be considered? No, because the apples received by any boy, okay, they should not be arranged in orders. Okay, so we have to remove the orders of the arrangements, okay, in which one student is getting. What is the order of apples? So that order is not important. We have to just divide, or we have to just distribute. Okay, but now the boys are different, so into 3 factorial. Similarly for second one, again 8 factorial divided by internal 2 factorial into 2 factorial into 4 factorial, but again divide by 2 factorial. Why? Because two things will look like same. Okay, and into 3 factorial. Okay, similarly for this one, last one, 8 factorial divided by 2 factorial into 3 factorial into 3 factorial. Okay, but again we can see here these two things will look like same. Okay, so we have to remove the arrangements of these things and into 3 factorial. So now solve it. After solving first one, you will get 1680. Second one, you will get 1260. And third one, you will get 1680 again. And now the total addition will become 4620. So number of ways of arrangement will become 4620. Option A. Okay. This distribution can be done, means different things in different boxes. Okay, and no box remains empty. So recall the method. Yes, this case 4, different things in different boxes. This one. Okay, so 311. So 5 walls are different, so 5 factorial divided by 3 factorial, 1 factorial, 1 factorial into just 1 minute, 1 minute. I think number of ways 8 non-identical apples can be distributed 3 boys such that every boy should get at least 1 apple and at most 4 apples. So 1 3 4. Okay, just give me 1 minute. I think one point I have to check it. Okay, now let's check the next one question. I will check it later. In how many ways 12 apples can be distributed among 4 children such that every child gets at least 2 apples? Okay, so in how many ways 12 apples can be distributed among 4 children such that every child gets at least 2 apples? Okay, so it means in this one case they are not saying different apples. So in this one case we have to assume that all the 12 apples are identical. All the 12 apples are identical. Okay, so each one child will get at least 2 apples. So first one we will distribute 2 apples to all the 4 children. So 2 apples, 2 apples, 2 apples and 2 apples. all the four children. Okay, first one, second one, third one, and fourth one. Suppose that the names of children are A, B, C, and D. Okay, so after giving these two apples, now each one is having two apples at least. Now remaining apples are, so total apples will become 8. Now remaining will be 12 minus 8, that is 4. So now we have to distribute these 4 apples among 4 children. So now 4 apples we have to divide in 4 children's. So we will use separator method here. Okay. So separator method means 4 identical apples. Okay. Now we have to divide anything in 4 parts. So anything can be divided in 4 parts just by using 3 cuts. Okay. So by using 3 cuts, so in this one case, the number of ways will be equals to, so 1, 2, 3, 4, 5, 6, 7. Total 7 things are here. 7 things can be arranged in 7 factorial ways. Divided by 1, 2, 3, 4 things will remain same, 4 factorial, and 3 separators will look like same. So 3 factorial. So it will become 7 factorial divided by 4 factorial into 3 factorial. Okay. So after solving this one, you will get 35 as your answer. Okay. Option A is correct. Okay. So anybody having any issue? Sure. Okay. So I think no doubt in this one. I'm just checking one more thing for here. No, I'm correct. Answer is correct. No confusion. So I think I have completed the whole topic. Okay. So thanks to all.